Section 91A is about some statistics, specifically analyzing data by using tables and graphs. We're going to start with a couple definitions, and then I'll run through a presentation and try to explain some graphs to you. The first definition is data. Data is just numerical information given to us in number format so we can do stuff with it. There are three kinds of graphs that we're going to look at. The first one is a bar graph. And a bar graph compares different categories of data. So if you break data into categories, that's a bar graph. A circle graph is the second one, and that compares parts of a set of data as a percent of a whole. So it's a circle, or sometimes called a pie graph, and you use that for percents. And then a line graph is a graph that shows how data changes over time. So if you want to compare things that change, you're going to use a line graph. Here we're going to look at some examples of the different kinds of graphs. This one we're going to look at a bar graph. Specifically, our bar graph here says the table shows a number of men and women participating in NCAA championship sports programs from 1995 to 1999. So the data in the table and on the graph is the same data. Notice, though, the data in the bar graph is a lot easier to see the trends and how the things change than it is if you look at the table. Now we're going to do some questions. Describe how you can tell from the graph that the number of men in NCAA sports remained about the same while the number of women increased. If you look at the numbers here in the table, you can't really tell that. But if you look at the orange lines here, you can see that in 95, the men were up here, just above 200,000, and they were also above that line in 98. So over the course of those years, it stayed the same. But notice the blue lines. You can see them gradually going up or increasing. So it's a lot easier to see the trend by using a bar graph than it is by just using the raw numbers. And that's what this says. The next thing we want to look at is to determine approximately. In other words, if we want to estimate how many more men than women participated in sports during 97-98 school year, would it be better to use the table or the bar graph? The key here is approximate. If you want to approximate something or just guess, it's better to use a bar graph because you can look at the 97-98 school year and you can guess the distance between those two. And so if you want an approximate number, you look at the bar graph. The next thing we want to look at is how do you determine the total participants, which means if you actually want to get a total number between the 1998 and 99 school year, it's better to use the table because you can actually take those two numbers and add them together. And if it asks for an exact number, you'll want to use the table. So now here's your chance. Take a look at the same graph and answer a couple things about it. Has the general trend of the difference between the number of men and the number of women increased, decreased, or stayed the same? Now we're talking about the difference here. So in the beginning, if you look at the bar graph, you can see that the difference is that distance, but then at the end, the distance is much shorter. So we would say that the distance, or the difference between the two, has decreased. And you can tell that a lot easier on the bar graph than you can on the table. Approximately how many more men than women participated in sports in the 96-97 year? Well, again, let's take a look. 96 is at about 130, I would say, and then this is just above 200, so I don't know, 70,000? Yeah, about 70,000. And we're just asking for an approximate, so that's good enough. And what was the total participation among men and women in 95-96? Well, if you just add these two numbers up, you're going to get 331,634. So you can see when a table of values is better than a bar graph, but you can also see the benefits of potentially looking at data in a bar graph. Now we're going to take a look at circle graphs or pie graphs. This one shows a poll in New York where it asked residents whether cell phone usage while driving should be banned. And if you notice, in a pie graph or a circle graph, all of the percentages need to add up to 100%. So 87 plus 10 is 97 plus 3 is 100%. If 250 people in New York were surveyed, about how many thought the cell phone use while driving should be banned? Well, what you need to do there is you look at the percentage that say it should be banned, and you multiply that percentage by 250, the number of people. Now when we multiply a percentage, we change that to a decimal. 0.87 times 250 is about 217.5 people, You can't have half a person, that would be gross, so we'll round that to 218 people. The next thing we'll look at is if a city of 516,000 is representative of those surveyed, how many people could be expected not to know whether cell phone use should be banned? Well, we find the part of the pie graph or the circle graph where they don't know, 3%. So we multiply by 3% times 516, and again that's 0.03 because you move the decimal 2 places to the left, times 516,000 is 15,480. So about that many people don't know. Okay, now a couple questions for you to maybe pause and look at. This survey talks about high school students thought their courses were challenging. If 500 students were surveyed, how many felt their courses were challenging? We find the yes part of the circle graph, and we're going to multiply 0.67 times 500. That's going to be 335 students. And the second one says this many students had no opinion. So we find the 4% and we multiply 0.04, because that's 4%, times 2350, and that's 94 students. The last kind of graph we'll examine is a line graph. And remember, line graphs are used to look at change over time. So down here we have the time, and we look at the number of students enrolled in the millions in higher education. How would the change in enrollment between 97 and 99 compare to the change between 95 and 99? So you look at the two. Since the enrollment between 95 and 97 is not very big of a change, then you would say between 95 and 99 and 97 and 99, it's about the same. And you can see that on the graph, how close 95 and 97 are to each other. Next one says, why couldn't you simply extend the line in the graph beyond 1999 to predict the number of students enrolled in 2005? Well, technically you could extend the line if you wanted to, but the graph that we have here is not large enough, so it would go off the edge of the graph. Now that doesn't mean we couldn't extend it, but in this graph it's too small. Now the next one says, estimate the change in enrollment between 96 and 98. Well, in 96 it's about 14.3, and in 98 you see 14.6, so what's that, about 0.3? Yeah, and you can see that difference in the line graph. And if the rate of growth between 99 and 2000 continues, predict the number of people who will be enrolled by 2003. So if you wanted to extend this line up here and just get an estimate for where it would be maybe in 3 years, you could do that. About 15.4 million would be a really good estimate.